The conservation of momentum principle states that the total momentum of your system before is going to be the same as the total momentum of your system after. This is an isolated system. So for problem 28, we have a 2 kilogram blob of putty moving at 3 meters per second slams into a 2 kilogram blob of putty at rest. So this describes our initial scenario. Show how the speed of the two stuck together blobs of putty immediately after colliding is 1.5 meters per second. So our after scenario is when they're moving together as a unit. So our working equation is then total momentum before will be the same as the total momentum after. We've got two objects for our system. So the first object before the collision has a momentum of 2 kilograms multiplied by 3 meters per second. Our second object is also 2 kilograms in mass, but it's at rest, so it's 0 meters per second. This whole term right here describes the momentum total before the collision. And then afterwards, they're moving as a unit, so it's just one mass with a combined value of 2 kilograms plus 2 kilograms and multiplied by a common velocity, which we're looking for. So this becomes 6 kilogram meter per second equals 4 kilograms times your unknown velocity, and the velocity is 1.5 meters per second. This is the speed of the two after they collided. To help us understand that problem, here is a simulation where instead of the blob of putty, we have carts. So your first cart here has a mass of 2 kilograms and an initial velocity of 3 meters per second. And it's going to collide with a second mass, which is also 2 kilograms, but it's going to have 0 meters per second as initial velocity because it was at rest. If the two objects stick together after collision, then that is characteristic of inelastic collision. So we're going to run this. Remember that the velocity that we calculated previously was 1.5 meters per second. Let's see if that's the case. So the two move together as a unit with a common velocity. Problem 29. Bowling Barry asks how much impulse is needed to stop a 10 kilogram bowling ball moving at 6 meters per second. What is your answer? So we're being asked for impulse here, and a formula for impulse is a change in momentum, which is the same as final momentum minus initial momentum. Final momentum being mass times final velocity. Initial momentum is mass times initial velocity. So our initial velocity is 6 meters per second, and since this one stops eventually, our final velocity is 0. So substituting 10 kilograms times 0 meters per second minus 10 kilograms times 6 meters per second give us an impulse of negative 60 kilogram meter per second. Joanne drives her car with a mass of 1,000 kilograms at a speed of 20 meters per second. Show that to bring her car to a halt in 10 seconds, road friction must exert a force of 2,000 newtons on the car. So our working equation here is going to be an impulse becomes a change in momentum. And change in momentum is final momentum minus initial momentum. So we have 1,000 kilograms times 0 meters per second, this being the final velocity, minus 1,000 kilograms multiplied by 20 meters per second, this being your initial velocity. And that gives us a momentum change of negative 20,000 kilogram meter per second. This is also our impulse. So we then use the formula impulse is average force times time, and our value becomes negative 20,000 kilogram meter per second equals the average force times 10 seconds. We can then calculate for the average force as negative 2,000 newtons.